Hello, this is Phil Thomas from New Era Systems. Today I'm looking at this exotic green BUC. I don't think there's anything very exotic about it other than the fact that someone has painted it green, probably for a military or semi-military application. Anyway, let's see what's here. First thing is we have a dummy load. The dummy load is here to absorb the radiation, the output radiation from that BUC. There is a cross-guide coupler. The cross-guide coupler allows me to use a power meter to take the output power reading directly from this BUC. This BUC is a little different in that, from most of the other 3 and 4 watt BUCs, in that it has a type N connector. One of the things that we always have to do here is keep a whole box of tricks connecting N to F, F to SMA, N to all kinds of different connections that we need to make. This one is going to be easy though, because I'm using an N-type connector on the output side of this modem. The modem is a Comtech EF Data 570L. It outputs L-band, 10 megahertz reference, and the 24 volts required to drive this BUC and to power it. With that said, all I need is a simple N-to-N cable. I mentioned the box of tricks. This is what we keep on hand. It's just about everything to change from anything to anything. And after this video, of course, it goes back into the safe where no one can find it and steal any parts. On the other side of the bench, you can see the front of this Comtech EF Data 570L modem, and on top of it, an Agilent power meter. Very nice digital power meter, and lying on top of it, this is the power head that connects directly to the cross-guide coupler. In many cases, these power heads are more expensive than the meters themselves. Not necessarily with this Agilent, because it's a very good power meter. So I'm going to make the cable connections now, turn on the modem and turn on the power meter. So I'll be back in a second. All of the connections are made now. The power head to the cross-guide coupler for measurement, the input to the BUC from the modem, and connecting on the output side of the modem, of course, to the BUC. One comment about this modem. It looks as if it's had a hard life. If you look at that connector, it's bent over to one side. The cord restraint is bent as well. What happens with a lot of these things is the people who sell them to us just do not take the proper care to pack them. When we ship out, we take extra care because we know what can be damaged and how easily damage can occur. I don't know a lot about this BUC other than the basics. It's 4 watts. It has an output frequency range of 14.0 to 14.5. So today I'm going to do a quick test at 14.25, right in the middle of the range. And I first have to make a note of the attenuation coming from this cross-guide coupler. Any signal coming out of the cross-guide coupler is going to be attenuated or cut back by 40.16 dB. That's important because I need to set that value up onto the power meter so that I can get an exact output. My first task is to make those changes on this power meter. So I'm going to go to offset, and looking down here I can see that the offset is already set to 40.16, so that means at a previous test that's how I left this. I don't need to make any more changes. The next thing I need to do is to make sure that the frequency is 14.25, and sure enough it is at 14.25. So this power meter is correct. My next job is to go down to the modem, go to the transmit. I'm going to go to the frequency range, make sure the frequency is set up at 14.25. Yes, again it is. Don't have much to do today. I'm going to go down to the power. This is the output power of the modem. The output power of the BUC is controlled by the modem. The more input you give to the BUC, the higher the output. Now, this is an attenuation, so minus 28 is low, minus 27 is higher, and so on and so on. So the less this number, the higher the output power. But I'm going to start at minus 28 anyway. Now I'm going to go to power on off, and I'm going to power on off. I'm going to turn the power on. Now immediately you see an output on the power meter is 1.52. And again, I don't have to do any calculations because I set the cross-guide coupler attenuation into this. The output that I see here is exact. So now I'm going to go once more to power, and I'm going to bring it down by a couple of steps. In other words, I'm going to increase it by a couple of steps. So when I take it to there, I press up. So I've gone from -28 to -26. The output now is 2.34 watts. Okay, we'll do it again. Going to take it up again, 2 more steps. 3.62. Okay, now this is a 4-watt buck. Okay, 5.23. If I was doing this in real life, prior to shipping this, I wouldn't be doing it in such large steps because I'd need to know where the saturation is. Even though the power of these bucks can increase beyond the design output, it doesn't mean that you can use it. Once you get into saturation, I always think of it like the sound of an audio speaker when it's been turned up way past and you get distortion coming out of the speaker. I know that's not exact, but that's the way I think of these things. Well, we know now that it will very easily go up to 5.2 watts. How much of that is usable? I just don't know, because I haven't taken the time to step through a 0.1 dB increase at a time. Because if I did that, I would expect to see exactly the same output coming from the buck. So it would be a 1-for-1 increase. And I would keep on doing that until the output from the buck doesn't match 1-for-1. It starts to drop off. In other words, a 1 dB increase would be a 3/4 dB output from the buck. And when that happens, you know that you've reached the saturation of the buck. Basically, you have to back off because you're out of the usable level. Okay, that's it for our exotic green buck. I said earlier when it was sold, it was probably sold at some ridiculous price. Well, we'll just pretend that it's white and we'll sell it at a normal, low-cost, new era price. Thanks.